Okay, this might be the most important lesson we've had this year. You've heard the word derivative a lot when it comes to calculus, and this is what it's all about. So up until now, we've been finding equations of tangent lines and slopes of tangent lines by using the difference quotient. The difference quotient is simply saying that if you take the secant of a line, the slope of the secant of a curve, and you take the difference in the x's and you subtract y minus y over x minus x, you can get the slope of this secant line. But as we get closer and closer and closer to this point, that change in x gets smaller and smaller and smaller and smaller, which this is where h approaches 0 in the difference quotient. Well, when we talk about derivatives, the derivative is the slope of the tangent. I'm going to say that 1,000 times. Derivative is the slope of the tangent. Derivative is the slope of the tangent. It's not the tangent line, it's the slope of the tangent line. So the change in y we call dy. Change in y is the difference in the y's, and the change in x we call dx. And we remember dx is a really, really, really small change in x. So here are 3 different ways you might see derivative written: dy dx, y prime, f prime of x. And now there's lots of rules and shortcuts for finding derivatives. That's what I'm going to talk about today. The first one I want to talk about is the constant rule. So for instance, if I said use the difference quotient to evaluate f of x equals 3, well, you would be confused because there's nowhere to plug in. So f of x plus h minus f of x all over h, limit as h approaches 0, it would just be f of 3 minus f of 3 all over 0. So it would be, you get the idea. The answer would be 0, because you're just talking about a horizontal line whose slope is constantly 0. So the first derivative rule, d dx of a constant, is 0. Okay, the next rule is the really important one, and this is the one that some of you have kind of figured out as time has gone on, and that is the power rule. Okay, the derivative of an x to a power is you put the power down in front and then subtract 1 from the power. So again, I would like you to use the difference quotient to evaluate f of x equals 3x squared. Pause the video and go ahead and use the difference quotient to show that. What you're going to find is that f prime of x, the derivative of x, is 6x. When all of this, let's just do it for the fun of it. The limit as h approaches 0, 3 times x plus h squared minus 3x squared all over h. This is x squared plus 2h plus h squared. When I distribute, I get 3x squared plus 6h plus 3h squared minus 3x squared all over h. 3x squareds cancel out. Limit as h approaches 0 of h times 6 plus 3h all over h. The h's cancel, plug in 0 for h, and we get 6. What happened? Where did the x go? Oh, this is 2xh. Geez, see what happens when I try to do algebra fast? So this is 6xh, so this is 6x. Final answer, 6x. So the power rule is simply when you have one term, you take the exponent, multiply it by the number in front, and subtract 1 from the exponent. And we are going to practice a ton of these. There's rules for the sums and differences of functions. Basically, as long as 2 functions are differentiable, then their sums and differences are differentiable, and you just do each term separately. It's very simple. Here are the 2 that you really have to understand. The product rule. What happens with the product rule? If you have f of x times g of x, the derivative is f of x times g prime plus g times f prime. Now here's how I say it. First times derivative of the second plus second times derivative of the first. And again, I'm probably going to say that a million times. First times derivative of the second plus second times derivative of the first. The quotient rule is very different, and it's tricky. here's how it goes. You always start with the bottom. Some tricks to this, I'll think of them when I'm done. I say bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. Someone that I heard that I learned from this summer said low d high minus high d low over low low. So low d high minus high d low over low low, low squared. If you want to remember that, fine. I think the low d high, as long as you can remember bottom times derivative of the top, the rest of it starts to flow, but you have to remember to start with the bottom. That's it for the rules. Now we're just going to do some examples. Okay, we're going to do a bunch of examples. Where did they go? Apparently 5 to be exact. No cheating. I'm going to cover up the other ones. Okay, the first one is, the directions here are find the derivative of the function, or in other words, find f prime of x, or find dy dx, or find y prime of x, just y prime. Okay, here you have a constant, f prime of x is 0. Very easy. Here you have one of two options. We could either distribute the 1/4, which I'll do that one first. So f of x equals 1/4 t to the 4th plus 2. And then you could take the derivative of each term and add those together. So f prime of x would equal 4 times 1/4 is 1. Subtract 1 from the exponent, you get 3. Plus the derivative of 2 is 0, so the answer is just t cubed. Or we could have used the product rule, and the product rule says first times derivative of the second, so first is 1/4, derivative of the second is 4t cubed, plus second times derivative of the first, which is 0, so that's just 0, and 1/4 times 4 cancels out. Either way, you get t cubed. So there's going to be a lot of times when you want to distribute because it'll be easier, and then there's going to be times where you're going to want to use the product rule because it'll be easier. In this case, I think they're both about equally as easy. I tend to go towards the product rule though. Okay, next example. This is a new problem here. This is just the derivative of a difference in a sum, so you do each term separately. So I'm going to do 6 times 1/2, so I'm going to write f prime of x equals 3t to the 5th. 4 times 3 is 12. T cubed, and derivative of t is 1 plus 1. That's it. Imagine having to do the difference quotient for all that. Sorry I tortured you for so long. Here's another example. I would use the product rule here, but if you prefer to multiply, let's do it both ways. So if I distribute, I get 2x squared. My outside is 3, my inside's -4, so I get minus x minus 6. So the derivative of each term is 4x minus 1, 0. Remember. But if I do the product rule, f prime of x, first times derivative of the second means x minus 2 times the derivative of this is just 2, plus second, 2x plus 3, times derivative of the first, which is just 1, because remember, -2 is a constant, so the derivative is 0. And now, if I distribute, I get 2x minus 4 plus 2x plus 3 for an answer of 4x minus 1, same answer. Now this one, this is our last example, because you're just going to practice a ton of these. Let's use the quotient rule. Quotient rule says bottom times derivative of the top, 0, minus top, which is -12, times derivative of the bottom, 5x to the 4th, all over the bottom squared, which is x to the 10th. So if I simplify this, I get 0 minus well, first I have to do this multiplication. So that's -60 x to the 4th, and then it's minus -60, so plus 60 x to the 4th over x to the 10th, which simplifies to 60 over x to the 6th. Oops, sorry, I didn't know you couldn't see all that. Now there's another way you could have done this one, and this is one of those situations where it's going to come in handy for you to understand algebra. You could have moved this up to the top and made it -12 x to the -5th, and then just used the product rule and done -5 times -12 is 60, Subtract 1 from the exponent, so you go down to -6, and then we write it as 60 over x to the 6th. Either way is totally acceptable, but you have to learn product rule, quotient rule, and power rule. So study those and be ready to, I think I'm going to give you some practice problems to go along with this. Okay?